Hey, GrowthChap family! Welcome back to the channel where we make complicated tech concepts easy peasy and super fun to learn. Today we're diving into the mechanics of large language models like ChatGPT. Ever wondered how this AI seems to know what you're asking, what to say, and how to say it? Don't worry. By the end of this video, you'll not only understand it, but you'll also be able to explain it to your friends using simple, everyday examples. Ready? Let's jump in. Before we explore the inner workings of large language models, LLMs, let's build a strong foundation by understanding three key concepts. Overview of AI concepts. Before diving into the mechanics of LLMs, first is the AI iceberg. Okay, picture an iceberg floating in the ocean. What you see above the water is just a small part, the tip. The real bulk lies hidden beneath the surface. AI works the same way. At the top of the iceberg, we have tools like ChatGPT, self-driving cars, or image generators. These are the cool, shiny applications we interact with daily. They're super impressive, but they're just the surface. Then, just below the surface, we find the middle layer, which includes large language models like GPT-4. These are the brains behind applications like ChatGPT, handling the heavy lifting of processing and generating language. And at the bottom of the iceberg, hidden deep below, we have the foundation. Massive data sets and training processes. These include terabytes of text data from books, websites, and even conversations that teach the AI everything it knows. So, the next time you marvel at AI, remember, it's an iceberg. What you see is built on layers of data and advanced models working invisibly behind the scenes. Next is key components of LLMs. All right, now that we've seen the iceberg, let's zoom in on the middle layer, those large language models. LLMs like ChatGPT rely on 6 key components to work their magic. Let me break it down for you step by step. Tokenization. First, the model breaks the input text into smaller parts called tokens. Think of it like slicing a pizza into bite-sized pieces. So much easier to handle, right? Embedding. Next, the model converts these tokens into numbers that carry meaning. It's like translating words into a secret numerical language the AI can understand. Attention mechanism. Now here's where it gets interesting. The attention mechanism helps the model focus on the important relationships between words, kind of like highlighting the key sentences when studying for an exam. Pre-training. Imagine the model is a student reading all the books in the world to understand patterns and language structures. That's pre-training in action. Transfer learning. Once the model has this general knowledge, it applies it to specific tasks, like answering questions or summarizing text. It's like taking everything you learned in school and using it at your first job. Generation capacity. Finally, the model combines all its knowledge to generate responses that sound human-like and contextually accurate. Every single one of these steps works together, creating the seamless experience we see in tools like ChatGPT. Finally, transformer architecture. Now here's the exciting part, the transformer architecture. This is the secret sauce that powers modern LLMs. Let's break it down into its main components. First, we have the encoder, which processes the input text, breaking it down and analyzing it in detail. Then there's the decoder, which takes that analysis and generates the output text, crafting responses that make sense. In between, we have the feed-forward network, which helps the model refine its understanding by running the data through multiple layers. And finally, there's the multi-head attention mechanism, the star player. This allows the model to focus on different parts of the input simultaneously, understanding the relationships between all the words at once. The transformer is what makes LLM so powerful. It's fast, efficient, and incredibly smart at understanding context and generating responses. Next, here comes the main part, mechanics of large language models, like ChatGPT. Let's see how this AI seems to know what you're asking, what to say, and how to say it in step-by-step with an example. Step 1. Model prepares the input for processing. Every great conversation starts with a simple input, whether it's a question, a command, or just a random thought. But for the AI to respond, it first needs to prepare the input for processing. Think of it like cutting a pizza into slices. The whole sentence is broken into smaller pieces called tokens to make it manageable for the AI. Let's see the token with the example. The sentence is, how does a car engine work? Tokens are, how does a car engine work? Question mark. This process is called tokenization, the foundation of everything that follows. Just like you wouldn't try to read a book all at once, you break it down into chapters, pages, and sentences. AI breaks your text into smaller parts to understand it better. Cool, right? Let's move on to what happens next. Step 2. Model turns words into numbers. Okay, now that the model has its tokens, it needs to understand them. And guess what? For AI, words are meaningless unless they're turned into numbers. This process, called embedding, enables the model to understand the relationships between words. This can be done in 2 simple steps. First, it converts tokens to IDs. Each token is mapped to a unique ID using a vocabulary. Here is the example for tokens, and their respective token IDs are as follows. Second, it converts IDs to word embeddings. These IDs are passed through an embedding layer to create dense numerical representations of each word. Here is the example for token IDs and their respective word embedding. For instance, the word car might become 0.9, 0.1, and engine might become 0.8, 0.9. They're close in this multidimensional space because they're related. By turning words into numbers, the AI can now start working its magic. But wait, word order matters too, right? That's what we'll explore next. Next, step 3, model knows the position of each word. Just like in a sentence, the position of each word is crucial to its meaning. For example, the cat chased the mouse makes sense, but the mouse chased the cat changes the whole story. To keep track of word order, the model uses positional encoding, which gives each token a unique position in the sequence. Here's the token and its respective position. This is like numbering tabs in a binder. You know exactly where each piece of information belongs. Now the model not only knows the words, but also where they are in the sentence. Next, step 4. Model prioritizes keywords. In a sentence, not all words are equally important. For example, in how does a car engine work? Words like car and engine are far more important than does or a. The model uses attention mechanisms to prioritize these keywords by assigning them higher importance scores. Here is the token and its respective attention score. Think of this like highlighting key phrases in a book while studying. You focus on what's essential and ignore the filler. Next, step 5. Model understands complex relationships. Between words, language is full of nuances. Words depend on each other to convey meaning, and LLMs use a mechanism called transformer layers to grasp these relationships. It works in 2-step. First, contextual understanding. Transformers analyze how each word relates to others in the sentence. For example, car engine implies a mechanical device. Engine of a car means the same thing, but the word order shifts slightly. Second, multi-head attention. The model looks at every word from multiple perspectives. It might ask, how does engine relate to car? What's the connection between work and engine? This step is like solving a puzzle where each piece connects to others in multiple ways until the full picture is clear. Next, step 6, model grasps the full complexity of human language. Now, the model combines everything, meanings, positions, and relationships, to understand the sentence as a whole. Think of it like assembling a Lego set. The pieces are now snapped together into something meaningful. Next is step 7. Model decides what to say. Next, here's where the real magic happens. The model predicts the next word in a sentence based on everything it's processed so far. It happens in 2 steps. First is probability distribution. The model calculates the likelihood of different words coming next. Example, input. The car engine is. Predicted words with their probabilities. Running, 80%. Broken, 10%. red, 5%, a mystery, 5%. The model picks the most probable word, running, and continues the sequence. Second is sentence construction. It repeats this process word by word until it forms a coherent response. It's like playing a guessing game where every guess is based on deep understanding and probability. Now let's go to the next one, step 8. Model improves its predictions. The beauty of LLMs is that they learn and improve. During training, the model compares its predictions with the correct answers, adjusts its parameters to minimize errors over time. Think of this as a student refining their answers after receiving feedback. With every iteration, the model gets better at understanding and generating text. Now let's go to last and final step 9, adapt the model for a particular use case. Finally, LLMs like ChatGPT can be fine-tuned for specific tasks like writing essays, answering customer queries, or even coding. How it can be fine-tuned: developers train the model on specialized datasets tailored to the use case. Example: fine-tuning ChatGPT for healthcare might involve training it with medical texts. This is like teaching a generalist to specialize in a particular field, say turning a general doctor into a heart surgeon. So to wrap up, and that's how LLMs like ChatGPT work. From slicing your input into tokens to predicting meaningful responses, it's all thanks to these amazing step-by-step mechanics. If you found this helpful, hit that like button, share it with your friends, and don't forget to subscribe for more simplified tech content. See you in the next video. Bye for now.